Hello, I'm Philip Stoten. I'm at Productronica 2015 and I'm joined by Pete Starkey. Pete is not just an editor and a journalist, but is a very good friend from way back. Pete, thanks for stopping by to talk. It's a pleasure to see you.
It's a pleasure to see you, Phil, and thanks for inviting me.
There's a lot of talk about Industry 4.0, about this whole kind of joined up data-driven world in the EMS halls. Is that finding its way through to PCB? People are really driving a traceability requirement. Can the bareboard shops respond?
I think that they are trending in that direction, but quite honestly, and my many years of experience of the bareboard industry, they're pretty slow to move. They will eventually go in that direction, and I think everybody's thinking about it now. And there are one or two production examples of sort of putting this theory into actual practice in manufacturing.
Yeah.
And I think that new startup in Wayland in the US is a good example of that. A greenfield situation, so we've not got any problem of sort of trying to adapt existing equipment to future requirements. You're starting off with a total concept.
Yeah.
You're integrating that total concept. You've got a totally automated, totally integrated manufacturing line with sort of online quality assurance and etc. that will run lights out. So yeah. I think that's a great example. That's one example, but I'm sure there are many more.
Yeah, and it's interesting. I look at the PCB industry and my experience in that industry. There's a lot of processes that are controlled by feel, and we need to get away from that. We need to get away from something that is much more data-driven and much more volume-driven. So there is that traceability and reliability. Just to switch tracks completely, what's going on in terms of innovation in the halls? We hear quite a lot about high-speed laminates and the demands for LED and different sectors in terms of heat transfer. Is that keeping people awake in the other halls?
It certainly is. I think that recent technology developments are putting more and more demands on the substrate. The data transmission end is looking all the time for higher speed capability and lower loss capability. I think automotive now is becoming a big, I was going to say driver, but that's a bit of a pun. But automotive requirements where we're beginning to see driver assistance systems, collision avoidance systems, they're all working and requiring very, very high frequency radar type sensors. That's putting demands on laminate. If you look at the other end of automotive, the big trend towards electromobility, we're looking at a lot of high power requirements, and high power requirements demand probably heavy copper conductors, and they place all sorts of additional challenges to the PCB manufacturer. But the substrate has got to be a much more robust and durable substrate from a thermal point of view. Beginning to see similar requirements in flexibles, where flexibles have, even though they've been on a flexible polyamide substrate, they've had some sort of limitations in long-term operating temperature. But these limitations have been addressed now, so you're beginning to see flexible materials that will run continuously at 200 degrees C.
Yeah.
The revolution in lighting, the LED substrates need a lot of thermal management. The thermal management is popularly done using IMS, insulated metal substrates. From a PCB manufacturer's point of view, these are very difficult materials to machine. And your tools wear out very quickly, and as your tool wears out, you start doing mechanical damage and thermal damage to the substrate and reducing yields. So I think that's put a lot of pressure on the tool manufacturers, and the tool manufacturers have responded with improved materials and improved coatings such that they're self-lubricating and wear resistant. That's another area where stuff has moved on.
Yeah.
I think in terms of imaging, we've seen another revolution. when I came into the industry, people traditionally used screen printing as the means of producing their images. I was a young man in the industry when the trend was to replace screen printing with photomechanical processing, with dry film photoresist particularly. Although liquid film photoresist came before dry film, and now liquid photoresist has come back for many applications that are demanding fine line imaging. But we have done our photomech using contact printing. We've done it using photomasters. We've progressively eliminated the photomaster and gone to direct imaging. Yeah. But direct imaging tended to be an area where the larger manufacturers could afford the investment in the direct imaging machines, but it left the small manufacturers a little bit out in the cold. But if you look around the PCB hall, you'll see many direct imaging systems, particularly laser direct imaging systems now, coming in at affordable prices. You can, like the entry level price now is typically, say, €200,000, which again makes it an affordable proposition. And talking to a lot of, if you like, small to medium sized PCB manufacturers, what they're saying is they cannot achieve what they need to achieve to meet today's design requirements without LDI. Yeah. So that's another area.
Yeah. And that's an area you call revolution. I mean, I know the marketeers love the term revolution. For me, it feels much more like evolution, and it's quite a gradual process.
It's the adoption of a new technology. Yeah. We have grown up with. We started off making our photomasters from hand-taped artworks. We then generated our photomasters from CAD files. The technology of producing the photomaster changed from the typical vector plotter to the laser plotter, and then the laser plotter has evolved into the laser direct imaging system, and you're not just using that for your primary imaging, you're now using that at the end of the process for imaging your solder mask, because quite honestly you can't define the details that you need to define by any of the existing technology. So as a consequence of that, the LDI manufacturers have more powerful systems, two multi-wavelength systems, so that instead of the manufacturer of solder mask having to tune his photo initiator system to suit the wavelength of the laser, you can now tune the wavelength mixture to suit a particular photo initiator, so you're not bound to use one solder mask product. You can just have a series of different programs for it leaves the choices wide open in materials. I think another we talked about revolution, evolution. I think the revolution is a change in concept.
Real change in process.
Although it's had that revolution has had to evolve if you accept that. There's a lot of wet processes involved in PCB manufacture, and if you look at traditional PCB manufacture, there's always going to be a lot of wet processes, but there are ways of eliminating some of the wet processes. And for example, what we've seen as a photomech process for inner layers has now been demonstrated to be achievable by inkjet printing. So it's a totally dry process that environmentally isn't using any water or discharging any water or fumes or whatever. But I can see another opportunity. I've had a look today at a sort of an open air plasma system, whereas instead of having to stick your panels into a chamber and pump them down to high vacuum before you start generating your plasma, you're actually generating the plasma in a head in open atmosphere, which you can use for surface treatment, and I'm sure that this could be developed. It has lots of applications outside PCB manufacture. I'm sure that this can be developed for surface treatment, which will then eliminate the need for a lot of conveyorized wet processing. And I think in conveyorised wet processing, the traditional spray manifold, and there's a lot of developments happened in fluid dynamics that make that process more efficient, give that process a smaller footprint, and make that process more
measurable.
Exactly.
Less of an art, which is kind of where we're going. So actually, there's quite a lot going on in the bareboard industry, quite a lot going on in the halls B1, B2, and it continues to evolve and build.
When you think about it, there is.
Yeah.
But I think it needed you to provoke me to
find it.
to really think about it.
But it is that incremental improvement. We're not seeing it being data driven in the same way we are in these halls. We're not seeing the same revolution there. I think that has to come because traceability is required. You mentioned the automotive industry, they need it, medical, mill aero, they all need it, but it'll trend towards that.
Yeah.
Pete, thanks for stopping by. Pleasure to talk to you as always. Pleasure to see you, and I'll see you next time.
Always a pleasure to see you as well. Thanks
Thank you
very much indeed,
Thank
Phil.
you.